You hear them before you see them. The sharp crack of stone striking stone echoes through the cold morning air. Somewhere beyond the mist, a child laughs. A hunting spear scrapes against rough bark as someone adjusts it for the journey ahead. Smoke from a nearby fire drifts slowly through the trees, carrying the familiar scent of burning wood and roasted meat. Frost still clings to the grass beneath your feet, and every breath leaves a pale cloud in front of your face. You are not alone. Around you stands a family that looks remarkably human. They speak to one another with gestures, voices, and expressions that feel strangely familiar. They know this valley better than anyone. They have survived winters that would kill most animals. They have buried their loved ones. They have cared for injured companions who could no longer hunt. They have watched children grow into skilled adults beneath these same mountains. Yet none of them belongs to your species. Within tens of thousands of years, every human around you will disappear. Not because the Earth itself ends, not because humans go extinct, but because only one human species will remain. Yours. The greatest mystery is not why they vanished. It is why we did not. It is possible that Homo sapiens did not become the last surviving human species because we were simply stronger, smarter, or more advanced than everyone else. Archaeological evidence suggests that our survival may have depended on something far less obvious, an unusual ability to adapt, cooperate, and continue changing whenever the world itself refused to stay the same. For generations, people imagined human evolution as a simple march toward perfection. One species appeared, evolved into another, and eventually produced modern humans, as though history had been climbing an invisible staircase. It was an elegant story, easy to understand and satisfying to imagine. But nature almost never works that neatly. The deeper archaeologists dug into ancient caves and riverbanks, the stranger our family tree became. Fossils uncovered across Africa, Europe, and Asia revealed something unexpected. At many points in prehistory, Earth was not home to one kind of human. It was home to several. Different human species walked across different continents at the same time. Some hunted giant Ice Age mammals across frozen Europe. Others explored tropical forests. Some lived on isolated islands. Others crossed vast grasslands stretching toward distant horizons. For most of human history, being surrounded by other kinds of humans was completely normal. Being alone is actually the unusual part. That realization changes everything. Instead of asking how humans evolved, we suddenly have to ask why almost every branch of our family tree eventually disappeared while only one remained. The answer is far more complicated than scientists once believed. Our story begins in Africa, millions of years ago, where the first members of our extended family slowly emerged from earlier ape ancestors. Evolution did not suddenly create humans overnight. Instead, countless small changes accumulated across unimaginable spans of time. Walking upright freed the hands. Dexterous fingers made better tools possible. Larger brains opened new ways of solving problems. Each generation inherited tiny advantages from the last. But evolution never had a final destination in mind. It simply responded to whatever challenges existed at that particular moment. One of the earliest members of the genus Homo was Homo habilis, often associated with some of the oldest known stone tools. These tools were surprisingly simple, yet they marked an extraordinary turning point. For the first time, a species could consistently reshape its environment rather than merely adapting to it. A sharp stone could slice meat more efficiently than bare teeth. Bones could be opened to reach nutritious marrow hidden inside. Small innovations began producing enormous consequences. Then came a species that would completely redefine what it meant to be human: Homo erectus. If someone had been watching Earth from space nearly 2 million years ago, Homo erectus might have looked like the future of humanity. Archaeological evidence indicates that this remarkable species spread far beyond Africa into Europe and Asia, becoming the first human known to colonize multiple continents. They survived for well over 1 million years, making them one of the most successful human species ever to exist. To put that into perspective, our own species has existed for only a fraction of that time. Longevity alone suggests Homo erectus solved the problem of survival extraordinarily well. Researchers continue debating exactly when they mastered fire, but archaeological sites such as Wonderwork Cave in South Africa suggest that controlled fire may have been used surprisingly early. Whether every population possessed this knowledge remains uncertain, yet even partial control over fire would have transformed daily life. Darkness became less dangerous. Cold nights became more manageable. Food became easier to digest. Predators became easier to discourage. Around a campfire, something else may also have happened. People talked. They shared experiences. They remembered successful hunts. They warned children about dangers. Perhaps stories themselves began growing beside the flames. No fossil can preserve a conversation. No archaeological layer records the first joke ever told. Yet, it is difficult to imagine generations gathering around fire without exchanging far more than warmth. However, that was only the beginning. As hundreds of thousands of years passed, Earth's climate refused to remain stable. Massive glaciers advanced across the northern hemisphere before retreating again. Forests expanded and then disappeared. Rivers changed course. Grasslands replaced woodlands, only to become forests once more. Animals migrated, plants shifted, entire ecosystems transformed repeatedly. Every environmental change forced humans to adapt once again. Some populations became isolated from others for thousands of years. Over immense stretches of time, isolation allowed new human species to emerge. Europe gradually became the homeland of the Neanderthals. Across parts of Asia, another mysterious lineage evolved that scientists now call the Denisovans, known primarily from fragments of bone and remarkable discoveries in ancient DNA. On the Indonesian island of Flores, an even more surprising species appeared. Standing barely over 1 meter tall, Homo floresiensis puzzled researchers when its fossils were first uncovered. Popular media quickly nicknamed them the hobbits. At first, many scientists questioned whether these tiny skeletons represented an entirely different species or simply individuals with unusual medical conditions. Years of additional evidence gradually strengthened the case that they truly belonged to a separate branch of humanity. Suddenly, the human family looked far more diverse than anyone had imagined. Some species were tall, others were short. Some thrived in freezing climates. Others adapted to isolated tropical islands. Each represented a different evolutionary experiment. Each had survived because it fit its own environment remarkably well. None of them appears to have been an obvious failure. And that creates a fascinating problem. If Neanderthals could survive brutal Ice Age Europe for hundreds of thousands of years, if Homo erectus could persist for more than 1 million years, if Denisovans successfully occupied vast regions of Asia, if island humans could adapt to environments unlike anywhere else on Earth, then why is there only one human species alive today? The simplest explanation would be that Homo sapiens was simply better. For decades, that idea dominated popular imagination. It sounds reasonable. The surviving species must have been the superior one. Case closed. But archaeology has a habit of making simple answers far more complicated. Because the more evidence scientists uncovered, the more difficult that explanation became to defend. And nowhere is that mystery more striking than in the caves of Ice Age Europe, where another human species left behind evidence that would forever change the way we think about our closest relatives. For a long time, Neanderthals suffered from one of history's most unfair reputations. Early reconstructions portrayed them as clumsy, unintelligent cave dwellers who barely understood the world around them. Popular books and films often depicted them dragging their feet, grunting instead of speaking, and relying entirely on brute force to survive. They became the symbol of primitive humanity, a stereotype so powerful that calling someone a Neanderthal is still used as an insult today. Yet archaeology tells an entirely different story. As more discoveries emerged from caves across France, Spain, Belgium, Croatia, and other parts of Europe, the old image began to collapse. Neanderthals were anything but simple. They crafted sophisticated stone tools using techniques that required planning, precision, and considerable experience. Some of their spear points were carefully shaped through a process that involved preparing the stone long before the final tool emerged. This was not random smashing of rocks. It was skilled craftsmanship passed from one generation to another. Their hunting strategies were equally impressive. Archaeological evidence indicates that Neanderthals regularly hunted enormous animals such as bison, wild horses, red deer, and sometimes even mammoths and woolly rhinoceroses. These were not creatures that one individual could overpower alone. Successful hunts demanded cooperation. They required communication. They required trust. A single mistake could easily become fatal. This was already beginning to resemble the behavior of modern humans far more than many people once believed. Then came another discovery that challenged old assumptions even further. Some Neanderthal skeletons showed severe injuries that had healed years before death. Individuals with broken limbs, damaged joints, or serious disabilities survived long enough for their bones to recover. One famous example from Shanidar Cave in present-day Iraq belonged to a man who had lost the use of one arm, suffered major injuries, and may also have experienced partial blindness. Yet he lived for many years afterward. That could only have happened if others cared for him. Food had to be shared. Protection had to be offered. Someone had to help him survive. Compassion, it seems, was not invented by Homo sapiens. However, that wasn't the end of the story. Researchers also discovered evidence suggesting that Neanderthals may have buried some of their dead intentionally. The exact meaning of these burials continues to be debated, and scholars remain cautious about interpreting ritual behavior from archaeological remains alone. Still, several sites indicate that bodies were placed deliberately rather than simply abandoned. If true, that raises extraordinary questions. Did they mourn? Did they remember? Did they believe death meant something beyond the end of life? We may never know, but the possibility reminds us that emotional complexity is much older than once imagined. The surprises continued. Pigments, such as red ochre, have been discovered at several Neanderthal sites. Some researchers suggest these materials may have been used for symbolic purposes, perhaps decorating bodies, clothing, or objects. Eagle talons bearing cut marks have also been interpreted by some scholars as ornaments or personal decorations. None of this proves that Neanderthals thought exactly as we do, but it suggests that symbolic behavior may not have belonged exclusively to our own species. The line separating them from us became increasingly blurred. If Neanderthals were skilled hunters, capable toolmakers, compassionate caregivers, and perhaps even symbolic thinkers, then why didn't they survive? That question has occupied scientists for decades. One early explanation focused on intelligence. Perhaps Homo sapiens simply possessed larger brains. Yet measurements quickly undermined that argument. On average, Neanderthal brains were at least as large as those of modern humans, and in many individuals they were actually larger. Brain size clearly was not the deciding factor. Perhaps, then, it was language. Did Homo sapiens communicate more effectively? Some researchers believe complex language may have expanded cooperation and cultural transmission, although exactly when fully modern language emerged remains uncertain. Fossils cannot preserve conversations, and no archaeological site contains recordings of ancient speech. The debate continues. Even so, language alone probably cannot explain the disappearance of an entire human species. Neanderthals had survived changing climates for hundreds of thousands of years before Homo sapiens entered Europe. They were hardly newcomers struggling to adapt. This is where the story begins to shift. Instead of asking which species was smarter, researchers increasingly began asking a different question. Which species learned faster? The distinction sounds subtle, but it changes everything. Imagine two groups facing exactly the same problem. A sudden drought reduces available food. Large animals migrate elsewhere. Winter arrives earlier than expected. One group develops a clever new hunting strategy. But if that knowledge remains within a small community, its impact is limited. Now imagine another population connected to dozens of neighboring groups through regular exchanges. Ideas spread. Successful innovations travel from one region to another. Mistakes made by one community become lessons for another. Knowledge begins accumulating instead of disappearing whenever experienced individuals die. Some anthropologists describe this process as cumulative culture. It may be one of humanity's most powerful evolutionary advantages. Every generation inherits not only genes, but also information. Children no longer need to rediscover everything from the beginning. Instead, they start where their parents finished. That creates a remarkable effect. Progress becomes exponential. Archaeological evidence appears to support this possibility. Across Africa and later Eurasia, Homo sapiens produced increasingly diverse collections of tools. Instead of relying on a limited number of general-purpose implements, different tools became specialized for different tasks. Fine blades, bone needles, fishing equipment, harpoons, projectile technology, composite tools made from multiple materials. Each invention reduced risk in its own small way. None of them alone changed history. Together, they transformed survival. Yet perhaps the tools themselves tell only part of the story. The raw materials used to create some artifacts reveal something even more fascinating. Stone suitable for toolmaking has been found hundreds of kilometers from its geological source. Marine shells appear far inland, far beyond any coastline. Decorative objects sometimes traveled astonishing distances before reaching the places where archaeologists eventually uncovered them. People were moving. Objects were moving. More importantly, ideas were moving. These discoveries suggest that many Homo sapiens groups maintained social networks extending well beyond their immediate communities. If one region suffered poor hunting conditions, neighboring groups might provide support. If one population discovered a useful innovation, others could eventually adopt it. Large social networks acted almost like invisible safety nets stretched across entire landscapes. Neanderthals certainly cooperated within their own groups, there's little doubt about that. But some researchers suggest their populations may have been smaller, more isolated, and less interconnected across vast distances. If true, even minor environmental disasters could have affected them more severely. Small populations face difficult mathematical realities. Every harsh winter removes experienced hunters. Every disease outbreak reduces genetic diversity. Every failed generation makes recovery increasingly difficult. Sometimes extinction requires no dramatic catastrophe at all. Sometimes it arrives one family at a time. Then, just as scientists believed they understood the relationship between Homo sapiens and Neanderthals, genetics delivered one of the greatest surprises in the history of anthropology. The discovery was so unexpected that it completely rewrote one of the oldest assumptions about our species. It revealed that our closest human relatives had never been as separate from us as anyone had imagined. And hidden inside our own DNA was the proof. For more than a century, scientists believed the story ended with replacement. Modern humans entered Europe. Neanderthals disappeared. One species simply took the place of another. It was a clean ending, easy to explain and even easier to illustrate in textbooks. Then ancient DNA changed everything. Recovering genetic material from fossils once seemed almost impossible. DNA degrades over time, and the older the remains become, the less likely usable fragments survive. Yet advances in genetic technology allowed researchers to extract tiny pieces of DNA from Neanderthal bones discovered in European caves. When those ancient sequences were finally compared with the DNA of people living today, the results came as a genuine shock. Neanderthals had never completely vanished. They were still here, not as a separate species walking the earth, but as small pieces of inherited DNA carried by billions of people. Most individuals whose ancestry traces largely outside Africa possess a small percentage of Neanderthal DNA. The exact amount varies between individuals and populations, but the discovery itself overturned decades of scientific thinking. Modern humans and Neanderthals had not remained entirely separate. They had met, they had lived alongside one another, and, at least sometimes, they had families together. Suddenly, extinction no longer looked as simple as one species defeating another. Part of the Neanderthal story had continued inside us. The surprises did not stop there. In a cave hidden within the Altai Mountains of Siberia, archaeologists uncovered an unremarkable fragment of finger bone. At first glance, it seemed too small to rewrite history, yet genetic analysis revealed something astonishing. The bone belonged neither to a Neanderthal nor to Homo sapiens. It represented another human lineage entirely. Today we know these mysterious relatives as the Denisovans. For years, scientists knew almost nothing about them because only a handful of fossils had been discovered. Without DNA, they might never have been recognized as a separate population at all. But genetics once again revealed a hidden chapter of humanity. Just like Neanderthals, Denisovans also contributed DNA to living people. Some populations in Oceania and parts of Asia inherited genetic variants from Denisovan ancestors. One of the best-known examples involves populations living on the Tibetan Plateau. Researchers have found evidence that a Denisovan-derived genetic variant helps people cope with extremely low oxygen at high altitudes. That discovery carries a remarkable implication. Sometimes surviving did not mean inventing every adaptation from scratch. Sometimes Homo sapiens borrowed successful solutions from other human species through interbreeding. Evolution, it seems, occasionally works more like collaboration than competition. This realization forces us to rethink one of the oldest questions in human history. Did Homo sapiens truly replace every other human species? Or did we slowly absorb parts of them while other populations gradually declined? The answer may involve both. Some groups almost certainly disappeared completely. Others left lasting biological legacies inside our own genomes. The boundaries between extinction and survival suddenly become far less clear. Yet even interbreeding cannot fully explain why only one recognizable human species remained. Something else was happening across the prehistoric world. The Ice Age was entering another period of dramatic instability. Temperatures rose and fell. Rainfall patterns shifted. Forests expanded before giving way to open grasslands. Sea levels changed repeatedly as glaciers advanced and retreated. Entire ecosystems transformed within the lifetimes of many generations. Large mammals migrated. Some disappeared entirely. Predators followed new prey. For humans, every environmental shift demanded new decisions. Where should they hunt? Which plants remained edible? Which migration routes were still safe? How should clothing change as temperatures fluctuated? Adaptation became a continuous process rather than a single event. This is where Homo sapiens may have possessed their greatest strength. Not overwhelming intelligence, not unmatched physical power, but extraordinary flexibility. Unlike species that became highly specialized for particular environments, Homo sapiens repeatedly demonstrated an ability to occupy almost every habitat on Earth. Archaeological evidence places our ancestors in scorching deserts, dense tropical forests, frozen tundra, rugged mountains, river valleys, coastlines, and eventually even remote islands separated by open water. Each environment demanded different solutions, different food, different shelters, different clothing, different technologies. Instead of relying on one perfect strategy, humans kept inventing new ones. A community living beside a coastline learned to exploit fish and shellfish. Another mastered the migration patterns of reindeer across Arctic landscapes. Others adapted to forests filled with unfamiliar plants and animals. The remarkable feature was not any single invention. It was the willingness to abandon old habits whenever they no longer worked. Many researchers believe this behavioral flexibility became one of our defining characteristics. Nature kept changing the rules. Homo sapiens kept changing their answers. There is another factor that often receives less attention but may have been equally important: population size. Imagine two villages separated by hundreds of kilometers. One contains several thousand people connected through neighboring communities. The other consists of only a few dozen individuals, isolated by mountains or changing climate. Both experience a severe winter. Both lose hunters. Both suffer food shortages. Which community has a better chance of recovering? The larger network possesses advantages that extend beyond simple numbers. More potential mates preserve genetic diversity. More skilled individuals preserve knowledge. More neighboring groups increase opportunities for cooperation. Small populations, by contrast, are vulnerable to events that larger populations can survive. A disease outbreak, several years of poor hunting, a volcanic eruption, even simple bad luck. Extinction does not always arrive with dramatic explosions or legendary battles. Sometimes it comes quietly, one unsuccessful generation after another. Some researchers suggest this may have contributed to the gradual disappearance of Neanderthal and Denisovan populations. Evidence indicates they may have existed in relatively small, scattered communities compared with expanding Homo sapiens populations. If true, every environmental challenge would have placed greater pressure on their survival. However, scientists remain careful. No single explanation fits every region. different populations almost certainly disappeared for different reasons. In some places, climate may have played the dominant role. Elsewhere, competition for resources may have mattered more. In other regions, interbreeding blurred distinctions until separate populations slowly merged. The disappearance of other human species was likely not one event, but many different stories unfolding across thousands of years. That complexity is precisely what makes the mystery so fascinating. Human history rarely offers simple endings. But perhaps the greatest advantage Homo sapiens possessed cannot be measured in fossils, stone tools, or even DNA. It existed inside something far less tangible. An invisible inheritance passed from one generation to the next. An inheritance powerful enough to reshape the planet itself. And once it reached a certain point, the future of humanity would never be the same.